Hi guys, welcome to this series on feature engineering for data science and machine learning. In this video, we shall be focusing on the filter methods under the category of feature selection. The broad range of algorithms that we use under feature selection is called filter methods. The filter methods focus on understanding individual columns, describe the individual column in terms of statistics, removing irrelevant column or redundant columns, essentially give you a reduced set of features to build your machine learning model. Some of the prerequisite for this course, we need to be also prepared with some basic idea about statistics, some Python programming, and elementary knowledge of data science and machine learning, especially for the filter methods. So the topics that I'll be covering under filter methods is the concept of variances, how this is applicable to machine learning or data science, why low variances are a problem, and related to variances, concept of covariances. We'll touch upon covariances and the intuition behind covariances, and why covariance is so useful in machine learning and the most of the AI applications. Followed by covariances, we will talk about correlation, which is essentially covariance, but I will give you some insight about multicollinearity here. And after that, we'll talk about the various types of correlation, like Pearson's correlation, Spearman correlation, and Kendall-Tau, when to use which one. Other filter methods like information value and a huge list of univariate feature selection methods, mostly statistical in nature, like t-test, ANOVA, chi-square, and so on and so forth. We'll cover those under univariate feature selection. And finally, what Python provides us is a nice framework where we can use the univariate feature methods within the context of select k best. Essentially, it helps you set up the algorithms in a much easier way. So let's talk about the variance threshold method. It is very useful, it is efficient, and also computationally it doesn't really cost that much. And it's useful for large data sets and many columns. And as you know, the variance calculation is quite easy. You take the mean of a data series. Let's say you have these values and you compute the mean here and that mean and subtract the mean from every other element in the data series, sum them up. So essentially you're summing up the deviations and dividing by the number of samples. And that gives you a notion of a variance. That means how much a typical value in the data series is away from the mean. So let's look at the variance is a statistical measure. It quantifies what we just saw, dispersion or spread of data, or typical data from the mean. And it measures essentially how much individual data point is away from the mean. So the description is the variance is essentially the average of the squared value, and this is what we use to compute the variance of a data series. High variance means the data is quite well or quite spread out, which may be good, may not be good. We'll see each of these contexts. Low variance, on the other hand, it means the data is actually centered or clustered towards the mean. So both are extreme situations. We will have to apply domain knowledge and a data sense to make a call whether a certain variance is useful or not useful. So let's look at the typical way how we compute. Let's say that this is your data series 85, 90, 88, 92, and 87. Take a mean of these values and then subtract the mean from each of the individual values in the data series, square them up, and then add them and after that divide by the mean. So finally the value 5.04, which is what is variance of this particular data series. So you can compute the variance for population and a sample. So a slight difference here in terms of population means entire data set, and pretty much the same numerator, but the denominator is divided by the total number of samples, where it in case of in total number of samples in the population, and whereas in case of samples it is n minus 1. There is statistical reason why we divide by total number here and n minus 1. So that's how we compute the variance. Is there any accepted value or a norm or a best practice on what should be called high variance or what should be called low variance? No, there is no such definition. So the high variance is typically larger than 1. That's the definition pretty much used, but you will see many data sets have very high variance, like 500, 300, but they are perfectly okay. So you need to apply domain knowledge to make a decision whether this is really high or a low. So high variance means the data is well spread out. Low variance means it is centered towards the mean. So the recommendation is to set a threshold for high and a low after conducting series of experiments and understanding the data and the data spread, and then you set the threshold. So using the threshold, you can decide whether a value in the data series is high or a low. So we'll see how Python helps us in finding out the columns which are above the threshold or below the threshold. So what are the use cases of variance in data science? Quite a lot in terms of feature selection, finding the important columns, also describing or assessing the quality of data. The idea of variance is used. Yes, in terms of quality of data, if you have a very low variance, that means the data might be lacking some diversity in the data. On the other hand, if you have a very high variance in the data, that means that there could be some extreme values or outliers in the data set. We also use the concept of variance in the model evaluation. So let's say when you have a machine learning model and you apply a series of test runs on the model, and the results, let's say the mean square error or accuracies, and collect all those, and then you can look at whether the outcome or the metric is showing high variance or a low variance or consistent variance. So it is used in the model evaluation purposes as well. Why variance is important in machine learning? Some of the reasons that I have mentioned here. The low data with the low variance can mean that the data is lacking diversity, and diversity of data is important in machine learning for covering all situations or boundary cases or edge cases, um, in order to get the model which is well generalized. Low variance may lead to a data set that is not representative of the problem, or rather, when we go for predictions in future, it may not generalize well. Low variance in the future can also mean insufficient discriminatory power. All machine learning models, for example, traditional machine learning and deep learning models, are discriminatory. That means the model should be able to discriminate the data in terms of groups and classes. And if you have low variance, this could result in the situation where the model is not discriminatory enough, leading to poor generalization. This also means that low variance also means that the limit exploration of the feature space. That means you do not have diversity. Pretty much the same point like the first one, which is lack of diversity. Models trained on data which are low in variance may not generalize well for different scenarios. Let's look at how we implement variance threshold method in Python. We need to identify the data and the column, and also, most importantly, decide the threshold, and then apply the threshold to detect which columns are candidate columns for possible, dropping. This is used in the pre-processing phase of your machine learning. So essentially, we are going to compute the variance of each of the column. Then you specify the threshold, compare the variances with the threshold, and then find out which features are candidates for removal. So the idea is, the low variance column or a data with a low variance in the column may not be, good enough. So we can consider for removal. Now there are limitations with this method also. Low variance does not always mean poor data. Okay, so in this situations like variance threshold, we need to be very careful about setting the right threshold. So understanding of the data is important. Choose the right threshold is important. You should combine the variance threshold method with the other filter techniques that I'm going to be showing you in this video series, and also look at the features selected in different conditions, like with a different variance threshold. Apply those and come up with the model performances, and then compare the model performances. Next, I'm going to show you how to implement variance threshold in Python using scikit-learn. Okay, so this is the code for variance threshold. I'm just going to show you some of the important lines here. So for variance threshold, we're going to use scikit-learn, and the package is called variance threshold. You can choose any dataset. So in this example, I'm using the iris dataset, and the objective is to find out, based on the threshold, which columns are candidate for removal. So these are columns here, these 4 columns, and just take the 4 columns and set up the variance threshold with the threshold of 0.5, and then fit the data. So when you fit the data, it's going to return you the columns which are above the threshold of 0.5. So here the column numbers 0 to 3 are candidate columns for good columns. The column number 1 here not mentioned. That means you can actually consider column number 1 for dropping. Look at the variances of each of the column here: 0.6, 0.1, 3. So 0.5 was our threshold. So 0.1 is below 0.5. So that means the column number 1 or index of the column number 1 can be considered for removal. So let's look at another one. Here is the California housing. So get your data X and Y. Set the threshold. So let's say it's 0.6 and fit the data. Here the get support means these are good columns, and the column which are not good is not mentioned here. For example, column number 3 here. Between 2 and 4, 3 is missing. And that's missing because of the variance here. If you notice, 0.22 is less than 0.6. So that is, the column that you can consider for removal. So pretty simple algorithm. Um, Now this package also has transform method. That means you can remove the column right away, but that's not something that we do in our pre-processing. Essentially, to collect the information first by applying these methods, and then make a list of choices of columns after applying other methods, and then you come to a conclusion which columns to keep and which columns to drop. The code will be available in the description in the YouTube. So that's it. I hope this was simple enough. So that was the example of how we implement variance threshold in Python. In the next video, I'll talk about the covariance. Thank you. We'll see you in the next session.